Good morning, everyone. Today we will introduce the chapter 4, chromatography. Okay. Open your textbook on the page 92. Okay. Your textbook, page 92. Okay. The chromatography is a technique employed for separation of the components of the material by distribution of the components between the mobile phase and the standard phase. Okay, so the chromatography is a combination of the two words, including the color and the gravity of the two, right? Okay, so the chromatography is the collective term for set of laboratory for the separation of the pictures. So there are very two important issues of the chromatography, including the mobile phase and the standard phase. So what is the mobile phase? The matrix is stored in the fluid called the mobile phase, okay, which carries its through the structure holding another material is called the standard phase. Okay. So the next page. So what is the chromatography? The history of the chromatography is first employed by Dr. in 1906. Okay? So the primary for the separation of the pigments. The pigments is the color, different color. The substance including the chlorophyll, carotenes, and the central film. And there are different colors such as green, orange, and yellow respectively. So I have a question to ask everyone. What is the intent to analyze the pigments? What is the intent for analysis the pigments? Is eyes, right? Because it's the colors, right? Okay. So conversely, in modern analysis, some substances are colorless, like the coffee, right? In our chapter 5, the UV spectrum, we can discuss the UV spectrum is maybe some substance is colorless, so the detector is another like the UV, like the invisible detector to analyze the substance. But the result, the substance is pigments. There are different colors, so the detector is with eyes, right? Okay, so this will detect the color with the tyrosine carbonate. The tyrosine carbonate regarded as the standard phase, and then at each end from the left along with each of the leader and the sun. What is this? In general, the color like this is the glass tube. Okay? We can put the cotton in the bottom, or the cotton. You know cotton? In war, we can put the cotton in the bottom and making the standard phase in this color. Okay? And then you will sample over the engagement loading above the standard phase. Okay? Then we use the mobile phase to begin. The mobile phase in this case is either and this. Okay, this is the process of the chromatography. Okay, so mobile phase and the standard phase I will discuss it later, and I will explain it later. Okay. The mobile phase is known as the in okay? Okay, so this is the process. Okay, in detail, we will discuss what is the standard phase and the mobile phase. You can open your book, textbook on page 93, 93, your textbook 93. You can see the mobile phase and the standard phase. Okay, the standard phase refers to the time spent by substance when it's either moving during the chromatography. So important concepts is, and you can note in your textbook. You can note in your textbook the standard phase regarded as phase. It's phase. Sometimes it's the powder, so it's the fixed and the immovable, such as the kerosene carbon. And it is, you can note this. So another is the mobile phase. The mobile phase refers to time spent by the substance. It's moving, is in the solid, can be regarded as moving, such as the either and or another organic solid. Okay, so many different types of the chromatography and the liquid chromatography. The mobile phase is liquid. In the gas chromatography, the mobile phase is gas. Is different. So there are several different types of chromatography, and the use of each depends on the type of feature and the substance being studied. All, however, work on the same idea: standard phase and the mobile phase, and the length time each substance spends in either one of these phase during the chromatography process. Okay, this is a very important concept. You can note in your textbook. Okay, so this is the photo show the eluting chromatography of the chromatography. So we can discuss why the square substance and the triangle substance. Why the square substance moves fast and the triangle substance moves slowly? Why? Okay, the process involves the affinity of the chromatography. We can extend the molecules that are more soluble in mobile phase, enter the mobile phase, and move fast down the color. Otherwise, the molecules that are less soluble in mobile phase spend more time and move slowly. Okay, so the process involves affinity. We will discuss it later. Okay, this is important. Okay, in detail, we can explain separation occurs due to the different condition between the mobile phase and the standard phase. The different phase in the mixture spends different amount of time in each phase if they are all start for the chromatography process at the same time. What is this? You can see the picture. The substance A and the substance B. The start time is the start of the chromatography is at the same time in the days. Okay, through the chromatography process, why the substance A moves slowly, the substance B moves fast. Okay? This involves the affinity. Okay, we can discuss it precise substance can be further analyzed as they get separated. Chromatography and the substance can even be identified based on the length of time they spend in each phase. I will use the simple example to discuss. Okay, if there have a string, okay, and everyone are big. Okay, there have a string and everyone are big. All the component. Okay, substance A, B, C, D, E, F, G, okay, component, and the I and the mobile list. I push everyone, go far with this string. Okay? So in the beginning, everyone in the start, the time is set. Okay? So the string has the substone, like the cosmetic, like the game. Okay? So the sum arrow attach the cosmetic stone at the start, but some boy not interested, so move up like this. So arrow starting this and the boy move up. So separate. Otherwise, some boy are interested again the stone at the start, but some girls not interested. Okay, so what the substance A and the substance B that moves fast and slow. You can use this example to explain. It's simple. It's an example. Okay, so in detail we can explain the activity. How much time a substance spends in one phase compared to the other is referred to as its affinity. The affinity included like the molarity and the associability and the solubility. You can see your textbook 93. Sentence 2, line 3, like this. The affinity including three properties, like the property and the associability and the solubility. Okay, this is in the affinity. The Chinese is say the tingling. Okay. So it's a very important concept. The affinity of the substance for either phase can be affected by the solvent used for the mobile phase or the material used for the standard phase. Okay, so this is important concept. We can discuss if the substance or the component is polar. For example, then it will spend more time in the polar solvent of the mobile phase compared to the standard phase during the chromatography. Otherwise, if your non-polar substance is a non-polar substance, will spend more time in the standard phase. What is the same? You can say this is like very important concept. This is like if the affinity of the mobile phase for a component is greater than that of the standard phase, the component will move at fast rate, like the substance B. Okay, what is B? The substance B, the affinity is greater than the standard phase to the substance.
everybody updates your spot.com.
The important concept you can recall what is the miscible solvent or immiscible solvent. The liquid chromatography, like the partition mechanism, we should use the two immiscible solvent to treat the non-polar, high-polar. Okay, so you can see the video to understand.
Okay, thanks a lot. And today I'm going to show you a little bit about a technique called liquid extraction. In fact, I'm going to give you a very basic introduction to the principle. Now, this device right here is a sucker, and it contains a pear-shaped body.
This is two immiscible solvent, right?
The bottom,
The up and the down.
and of course, there's a port here on top, in which I can add things. Now, right now, my separate curriculum is only the ionized water. Now, I've also got a solution here. This is a solution of some blue dye molecules in N-butanol.
And this is our sample or our etchant, okay? So maybe this is very complex substance. Maybe have A, B, C, D, E, F, G, very much component in this triangle process.
Now, N-butanol is now added alcohol, which is immiscible with water. That means that they don't mix together intimately in the same space. So if I were to put this N-butanol solution into this separate particle of water, the two are not mixed up. And in fact, to demonstrate this phenomenon of partitioning, which we rely on this technique, I'm going to do something you wouldn't do in a normal liquid extraction. That is, we're going to add this solution very, very carefully, layer it on top of the deionized water receptor. And as soon as I get that done, I'll be right back to show you how liquid extraction is. Okay, we're back. So I've got a little tiny bit of that butanol solution later.
Okay, he put the compound or etchant in this funnel. You can see the two immiscible. So I have a question to ask. Why? The solvent, different solvent. Why is in the down, is in the up? Why? What is the difference? The specific gravity, right? Specific gravity different. So you can see the some solvent is down. The specific gravity is large and the small in the up. The large, okay?
Here's on top, using a transfer power pad. And now I'm going to add the rest very, very carefully so that it doesn't disturb the water layer. And because N-butanol has a density of about 0.8 or about 80% out of water, if I add it very carefully, I should be able to get that butanol to layer on top very nicely. Now again, you wouldn't do this during a normal liquid extraction experiment because ultimately, as you're about to see, our goal is to mix the two thoroughly. But for now, I'm just going to layer it on there gently so you can see the two solvents are definitely immiscible. Create two different phases. A little bit of a mess there, but not too bad. Okay, so here it is. Before the actual extraction procedure is taking place, you can see I've got my blue dye, my butanol, and my pure deionized water beneath. Now the dye.
Okay, so the liquid chromatography is the partition mechanism. It's very suitable to pre-treatment separate because our etchant or our sample is very complex. So use this method to separate the different polarity, like low polarity, medium low polarity, medium high polarity, and high polarity. Okay, we can separate regardless of pre-treatment.
I don't know, people really don't want to be here in they really want to be down here in the deionized water. They're more soluble in that solvent. But right now, I have haven't given them a way to get there yet. Because they only have this thin little interface between the two across which they can move. So I'm going to give them a little bit of help by agitating this mixture, creating many, many small inclusions of one solid to the other, and thereby creating a massive amount of surface area through which these blue dye molecules can move, essentially giving them the choice of the salt they want in. So let me do that now. Just a nice, gentle application. And if I wait for a few moments, the two immiscible solids separate from each other. But we should notice something that's happened. If we look a little bit closer, we can see that the blue dye molecules are beginning to migrate into the aqueous solution. And if I give myself enough time and attention, I can get not only some, but almost all of these dye molecules. All right, let's let it isolate itself one more time here. See that now we've actually got a darker solution forming underneath than we do on top. And this is our evidence that these blue dye molecules would rather be in the aqueous layer. There's something more soluble there. Now this is where stem on the bottom and stop on the bottom of the separatory flag. If it were my goal to remove my N-butanol from my dye molecule with my N-butanol solution, I can simply open the stop valve and drain the aqueous layer out bottom. Here we go, separation is starting to really take effect now. You can see that N-butanol layer very, very light in color, and the aqueous layer is much, much darker. So I'm successfully extracted dye molecules from the N-butanol solution into an aqueous solution, which I can simply collect by opening the stop top and draining only the aqueous portion of my mixture. So this is the principle on which liquid extraction takes place. Compounds partition.
Okay, so this video you can review it later. So liquid chromatography, like the treatment to separate the very complex substance and large polarity, low polarity, high polarity. We can use this method to separate. Okay, so you can note this, the general solid for chromatograph. You can note in your textbook, the up is the normal phase and the down is the reverse phase. And we will discuss later. But you should note the general solid for chromatography. Okay, so the normal phase, this way is non-polarity, lipophilic, and this way is polarity. Okay, it's hydrophobic. Okay. You can note in your textbook. Okay. You can note right in your textbook because this is important. This further. The normal percent is common use for extraction the urine oil. Okay, so it's lipophilic, and the second is dichromycin, and ethyl acetate, and acetone, and methane. Okay, the polarity is not polarity. This is polarity. Okay, and the reverse phase is acetonitrile, smaller than the methanol, smaller than the ethanol. this smaller or more is in the statistical gravity. The gravity is large is up, and the gravity is small is up. Like this. Okay, like this. The statistical gravity is in the Chinese is 宇宙。All right, 1, 2, 3, 4. Okay, you can take a picture slowly because it should be noted. This is very important. And then you can know this. The statistical gravity Chinese is equal. Okay? So in general, we use the EA and the water, or the chloroform and the water. Okay? And the methanol, 10% methanol, 90% water, and normal percent for supplement with the different polarity to the component. Okay, we can see the slide. If you have a sample like this, but the sample very complex, have the large polarity, medium polarity, low polarity component in this sample. The sample extracted with the ethanol, after the ethanol extract. So the partition with the two invisible solvent, like the HCl and the water. You can see, okay? This is two invisible solvent. And the further partition with the two further invisible solvent, like the water and the methanol combination and the normal acid. So we should be separate the normal acid layer, methanol layer, and the water layer further partition with the butanol and the water. We can separate the two elements, the butanol layer and the water layer. Okay, so the left and the right is mean the non-polarity. Okay, medium low polarity, medium high polarity, and the high polarity. So we use the equilibrium chromatography regarded as treatment to separate the different polarity of your sample. Okay, we can see like this. The picture is mean the EA and the water two invisible solvent. Okay, we put our sample in this form and put the two invisible solvent EA and the water in this. We can mix away, and wait for maybe 5 minutes. Okay, we can see the invisible. Okay, so the 1 time, the 2 times, and the 3 times, we can separate the different polarity component of your sample. Okay, so this slide very important, should be noted in your textbook. Okay, open your we can discuss what is the retention time and the definition. Okay? So the retention time is say evaluate the compound comes out the elite of the end of the current, the time from the start of the separation to the east from the system is known as the retention time. We can regard the TR or RT is the same. Okay? The time is taken at the time of the peak. So we can see like this. This is in the old current, like this. Or we put the cutter in the button and making the standard phase in this current and loading your sample above the standard phase and then further use the mobile phase to induce like this. So what is the retention time? Okay, the retention time is very important in chromatography as we use this time to identify the compound. Finally, we inject a non-standard identify its retention time in the chromatography. We then compare this time to a peak in the sample chromatography. If the time match, then there is a high probability for identifying the sample. What is this? So you can see this picture. Maybe at the substance A, B, C, the red, blue, and green. Okay? So when the start in this eluting process, you can see this peak. So the start and the your peak above the time is in the retention time. Okay? So the red substance have the red substance retention time, blue have the blue retention time, and the green substance have the green substance retention time is different. Okay? Okay, so open your textbook on 97. You can see like this. The substance A, the B is this. Okay? Through pass down of the current process. Okay, we can see the A and the B to substance. And the A is moving fast. So you can see to start and observe this peak. This time is mean the A substance retention time. And another B is moving slowly, so you can see this time is 0 to this time. How much time is mean the start to observe the peak. Okay? This time is this retention time. Okay, so everyone, you can open your mobile phone to scan this QR code without the Q&A. Okay. Please. Okay, please scan the QR code. And the question, we have 5 questions. Each question you will take 45 seconds to answer. Okay? question. You have 45 seconds to answer. Please choose the correct answer or incorrect answer. Okay? So question 1, which is the standard phrase for using to separate the literature by a Dr. Mikama suit in 1906? We can discuss in the room. The Dr. teaching use which is the standard phrase in this color. You can choose. A is silicon, B is kerosene carbonate, C, CAD, and the green is charcoal. Okay, very good. Okay, next. Okay, the second. Which one is the incorrect? Attention please, incorrect answer to describe of the infinity. The answer in your textbook is okay. Which one is incorrect answer to describe of the infinity? The red is polarity, the blue is solubility, and the yellow is absorption ability, and the green is statistical gravity. Okay, which one is incorrect? Okay. The answer is this. Okay, right? You can see the textbook, the 93, the set and graph 2, the line 3. The Chinese is say, the meaning in Chinese is say it's qing. Okay, right? You can see in the textbook. So polarity, absorption ability, and the solubility is mean the 极性、吸附力 and the okay. So this is incorrect. Okay, next. Okay, the third question. Which one is the correct? Okay, correct answer of the two mixtures soda. Miscible, not immiscible. The red is acetone and the water, and the blue is EA and the water, and the yellow is dichromethylchloroform and the water, and the green is 10% methyl and the normal. We can discuss it further. You should be note in your textbook the general organic solvent for separation. So the correct answer is this, right? Okay. The air and the water is immiscible, and the dichromethane and the water is immiscible. Okay, so in this case, what is the solvent in the bottom? What is the solvent in the upper? The chloroform and the dichromethane, the statistical gravity more than water. So this solvent is water, and this solvent is upper. Right? Okay? And the 10% methyl because at the 90% water, and the acid is invisible. So this question, which one is the correct answer of the two miscible solvent? Correct answer is acetone and water. Okay, next. measure of the time and the green measure of the picture. Okay, so the correct answer is this. The retention time is mean. You can spend how much time from the start to the peak shot you and observe this picture. So this time is mean the retention time. Okay, so it's not resolution. The peak shot is incorrect. The width is mean like this. Then this is big. And the best number is in this. Okay, so it's incorrect. So correct answer is measure of the time. Okay, the final question. Okay, the final question is, say which one is incorrect. Okay, attention please. Incorrect answer to describe the mobile phase. Mobile phase, the numbers of mobile phase. Which one is incorrect to describe? Okay, the red is yield, and the blue is solid, and the base, and the yellow is moving, and the green is fixed. Incorrect answer is this. The fixed is with the standard phase. The mobile phase is moving, and the regards of the idiot, the Chinese is say the talk. Okay, you can regard it as a solvent in the liquid chromatography, and the gas chromatography. The mobile phase is base. Okay, so moving is correct. The incorrect is this. And this is mean the standard phase. Okay. Okay. So we can see the result. This question you can review on your statistical time or in your home, or you can review like this question. Okay, so we will discuss another chromatography in the Chinese and the next class. So in this EMI course, I will use the English to introduce. I don't know everyone. What is your thing? What thing this about of the EMI? What are you think about the EMI? Use the English is okay always. But it's very difficult. Difficult or very simple. Okay, but I think that this is the experience of the course, because generally we use the Chinese to introduce, but I think that some student is very difficult to understand for Chinese, right? Okay, so use the English is very difficult. Okay, okay, okay. This video we will upload the different polarity of your substance. Because our sample the iteration substance is very complex. Maybe have another very large polarity. We use this method to separate. We can further interested on the like